Okay, this is your key for the notes, starting with Appendix C, which is in the back of your book. We're going to look at properties of exponents, and this begins on page A14 if you would like to refer to your book at any time. We're going to look at some vocabulary. First, exponential form is used to show repeated multiplication. And in general, if b is a real number and n is a positive integer, this is our exponential notation, b to the nth power. So that means b times b times b times b however many times, and we call that n factors. And b is the base of the exponential form, and n is the exponent, which tells us how many times we are multiplying b by itself. Just another set of vocabulary for the word integer. Integer is a set of whole numbers, both positive and negative. Oops, it's a V, as well as 0. So we have our set notation. Put 0 in the middle. We want positive integers, so 1, 2, 3, etc. to infinity. And then we need the negative integers, so we're going to put those to the left, -1, -2, -3, and that comes from negative infinity, and then we're going to put the braces around each side for our set notation. So let's take a look at some properties of exponents, or exponent rules. The first one is the product property of exponents, and that's when you're multiplying powers of the same base. So same base b in this particular example. What you end up doing is adding the exponents together. So we have b to the m times b to the n, so the same base of b, and we're just going to add the exponents together. The quotient property for exponents, a quotient is a division, so if you are dividing powers of the same base, so you see here you have b to the m divided by b to the n. In that particular case, to divide them, we're just going to subtract the exponents. We just need to note here that b, the base, cannot equal 0 since there is a b in the denominator. Remember, dividing by 0 is undefined. So a few quick examples. Example 1, a squared times a to the 5th. Well, let's write that out the long way. A squared means a times a, and then we're multiplying that times a to the 5th, so that's 5 a's multiplied together. So a times a times a times a times a, and we can easily see from that that gives us a to the 7th. Well, let's apply our property for products, and we'll see that we'll get the same answer, and it's much easier. So that ends up being a to the 2nd plus 5, which again gives us a to the 7th power. So this is the application of our property. Example 2 is an example of the quotient property. Again, I'm just going to write this out the long way so you can see that it applies. Y to the 7th is y times y 7 times, so I'll write all of that out. Make sure we have them all. 1, 2, 3, 4, 5, 6, 7. Yep. Divided by y to the 4th. And you'll see that y divided by y is 1. Each of those cancel out, and then we end up with y cubed in our numerator. If we apply the quotient property, we see that's going to be y raised to the 7 minus 4 power. 7 minus 4 is 3, which is y cubed. Okay, let's take a look at our next property, which is the power property of exponents. So for any base b raised to a power, which is then raised to another power, so a power to a power rule, you may have heard that in your last series of books. When that happens, what you do is you multiply the powers together. So a power raised to a power, multiply the exponents together. Example 3, x squared then cubed. Again, I'm going to write this out the long way so you see that it applies. X cubed means x squared, x squared cubed means x squared times itself 3 times, which then again we can write out even further. That's x times x times x times x times x times x, which gives us x to the 6th power. Well, applying our property, we can just take the shortcut. That would be x to the 2 times 3, which we know is x to the 6th. So those properties are very useful. We don't have to write all of that information out. Next two properties kind of go together. The product to a power property. So we have a product, a multiplication of two different powers of different bases, and then they are being raised to another power. Well, kind of what's happening here is you're distributing this power that's above. So we get a to the m times p times b to the n times p as a power. Similar idea for our quotient. So quotient, we have a division of two powers of different bases, and they are being raised to the power of p. So again, we just need to apply that power of p to both of our bases, and we get our simplified answer right here. Okay, so let's apply that. Here we have a product. We have 5 times x to the 4th. Well, 5 has an exponent of 1, so if we apply our rule here, this is going to be 5 to the 1st power times 3, because we're raising that to the power of 3, and that's going to be multiplied by x to the 4 times 3. So we end up with 5 to the 3rd times x to the 12th, and if we have a number raised to a power, we can figure out what that number is. So 5 cubed is 5 times 5 times 5. Which is 125, x to the 12th power. There's our answer. Okay, so if we apply the quotient to a power property, in this example we're going to have p to the 5 times 4 divided by 2 to the 1 times 4, which gives us p to the 20th over 2 to the 4th. So our final answer is p to the 20th over 16. Two more properties. Next one we have is the property of negative exponents. It's standard form to write a simplified problem with positive exponents, so we'll need to get rid of negative exponents. So if you have b to the negative n, that's in the numerator. So if we want to make our exponent negative n positive, we need to change it to the denominator. So that becomes 1 over b to the positive nth. Same thing applies if you have a negative exponent in the denominator. To make it positive, you just move it to the numerator. Similar example that is next to it, if you have a quotient raised to a negative power, to make that exponent positive, you just flip the numerator and the denominator. And again, when we have a in the denominator, we have to signify that that can't equal 0. Then we have the zero exponent property. For any base raised to the 0 exponent, that is equal to 1. The only exception, we cannot have 0 to the 0 power. That does not work. Okay, so in our applications, we have example 6. Y to the negative 4th. Well, that's a negative exponent. We want to write it with positive exponents. It's in the numerator, so let's move it to the denominator. So we're going to have 1 over y to the 4th. And we can also write that as 1 over y in parentheses to the 4th power, because 1 to any power is 1. So those things are equivalent. Let's take a look at example number 7. This is 2 to the 1st power. And you'll see that that power is positive. It's a positive 1, so we don't need to change its location. It's already positive. The only one we need to change is d to the negative 7th. To make that positive, it's in the denominator, move it to the numerator. So we have 2d to the positive 7th. That's our final answer. And example number 8, we have the quantity x squared plus 1 all raised to the 0 power. Well, applying the zero exponent property, anything to the 0 power is equal to 1.